Do-do. We're in, baby. We're in the 2013 Chevrolet. It's the Cruze, or the Cruze. This fella told me that his money light comes on and off, and he's got a tire that keeps going soft. So we're gonna see. Ooh, she got one of these things. It's like Grand Theft Auto. She got a stick shift, so we're gonna start it up. Oh, it says service tire monitor system. I see. Okay, so we're gonna check that out for him. I'm gonna let this thing get booted up and connected, and we're gonna see why his light comes on and off. It's on currently. Probably an evap leak would be my assumption, but let's have a look. Let's see. Let's see which one is turning the mill on. Mill requested. Easy peasy. So those are the codes we have in it. What do we have? A 597, it looks like, a 598, and your classic 171. So we have fuel system lean, engine coolant thermostat heater control circuit, and engine coolant thermostat heater control circuit low. The top one, the lean code, is not requesting the mill, or the malfunction indicator light, or the money indicator light as I call it. The bottom two are the thermostat ones. So we will have to take a look at that. I believe these have a heated thermostat in it. I don't know if we've done a video on these in the past or not. But we'll take and pull it in. We'll see which tire monitor he has going wonky on it. We'll take care of that stuff too. Everything's a little cold here. See if I remember how to drive a stick shift. Last Chevy Cruze I worked on was diesel. Can't see around the corner here, so we might be getting hit head on. And nope, we're not. We're good. Rush hour must be over. So I grabbed us some code set criteria and just kind of a little bit of a circuit description how things work. It says the ECM controls the pulse width modulated thermostat. Thermostat controls coolant flow and regulates the engine operating temperature. Ignition voltage is supplied directly to the thermostat through a fuse. The ECM controls the thermostat by grounding the control circuit with a solid state device called a driver. The driver is equipped with a feedback circuit that is pulled up to a voltage. The ECM can determine if the control circuit is open, shorted to ground, shorted to voltage by monitoring the feedback voltage. Conditions for setting this code: ignition on, it runs continuously. So that's that. We can find sometimes circuit tests to see what kind of resistance this heater should be, and just see if it's open. It probably is. Let's see here. See if I can find that for us here in service data somewhere. That's usually where they hide it, if they have it as a test. I don't see it there right offhand just looking at it. One thing I do want to know is, can we use our scan tool to just turn that circuit on and off? So that's what we're going to look at. We'll pop back in here, and then we'll pop back out to some kind of active test to see if we can just check, make sure that circuit works, and then then we'll move on with our life. Let's see here. Auto start, stop, this and that. Mass airflow, mill light. Intake tuning valve. Oh, here we go. Engine coolant thermostat heater. Skipped right over it first try. Key's not on. Turn the key on. We'll try this again. See if it's just an on-off deal. Engine coolant thermostat heater command right now is at 100%, so we should be able to just stick a test light on it and away we go. But we can decrease it down to 80%. Open circuit test, it says it's okay. Let's see. Heater circuit high voltage test, it says it's okay. That's interesting. But malfunction, it says low voltage test is a malfunction. So let's go out and check to make sure we're receiving voltage and the command there. And if we are, we'll check the resistance on the heater and we'll move on with our life. So I grabbed this little wiring diagram here. This is our engine coolant thermostat heater. It says left rear of engine, so we're looking for a violet with blue and a blue wire, which I believe is this one right here, right on the very front where the, I guess, I don't know if That's, yeah, it'd be the upper radiator hose goes in, so the outlet sits right up top here, so pretty easy to get to, and it looks like the blue wire is the control wire, so that's the one that's going to be grounded. Our violet with blue should be the power wire, so we're just going to take and unplug it. I don't see any crusties on it. Grab a test light here. So we have a test light, we'll hook this right to battery ground. We'll make sure our test light works. Our test light works, and then violet with blue, we probably can't get in there. Let me grab a pin here. We'll take and just grab a T-pin, and we'll pop in there. The key is already on. We'll just see if we have power on it, and we do. So we have power on it. Now we just need to see if we have control. So that's easy enough to do. I'll just grab a test light with a couple pins on it. Key's on. It said it was at 100% already, but we did unplug it, so I don't know if it shuts that circuit down. So we're going to pop back into our data here. Let's see. Heater, coolant thermostat heater command is at 0%. So there we go. Now we're at 100, and you can see it lights the light up. Turn that off, and then now we should be able to decrease it, and you can see it's pulse width modulated because our light is blinking. So that's that. It looks like we have good control. Oh, it just shut itself off for some reason. Yeah, command is at 0. Not uncommon on a GM to have a test only last so long before it shuts itself off. So we know that portion of it works. We can check the resistance on it, see if it is open circuited, or see what kind of resistance we have. I did look through service data and I don't find it published. I got a DVOM here. We'll make sure our leads are good. Always test your test equipment. Make sure we're at or near 0. We are 0.1 ohm. So I'm just going to go across these two terminals, and we are at 83, 84 kilo ohms. So about 86 right now, 87 and climbing. So 88,000 ohms. And we know that's way too high to make any heater work. I would imagine this thing would be at 30 ohms, something like that. Definitely not 88,000. So piece of cake, easy 1-2 diag. As far as the old code, the history code that's in it for the lean issue, we're not going to track down right now. We'll get this fixed, and then kind of take that from there. I can look at the freeze frame data on that, or we could start it up, see if the engine's running lean right now. These cars do have issues with lean problems, but like I say, that was not a code that's currently telling the engine light to turn on. So we're going to address the current problem. So I've got us a new thermostat housing coming from Napper, but it won't be here till this afternoon. We're going to go through. We're going to use our Altel. This is the TS508WF. That stands for Wi-Fi. It's a TPMS tool. We're going to select Chevy, then we'll get Cruze. We're going to go through and see which one of these sensors is bad. This is the 13 to 15. So we're going to go through and trigger every individual sensor, see which ones work, which ones don't. That tire is definitely low, as he indicated. So we'll just go around the car, because one of them's not working because we have that TPMS light on. And last but not least, well, what do you say, huh? So they all work, and they all seem to work pretty well. Battery status on them says they're all okay. The left front is low, obviously, at 23.9 pounds. Now with the service TPMS light on in the vehicle, I'm going to assume, being that they all work and we tested them where they're all still cold, I have to assume at that point somebody put it in programming mode and then never finished the program, or something got goofed up there. So what we'll do, I'll have Josh fix that left front tire, whatever's leaking on that. We'll blow them all up to the appropriate pressure, reprogram it, and make sure everything's okay. Something there, Josh. I don't know what's in the tire, but there's something right there, so we're going to mark that. Wherever it was, I just lost it already. Right there. So So I'm gonna have Josh break this down, see what's going on in there. We'll get that patched up. Poking apparatus, see if there's still something. Yeah, there's still something in there. Let's see, nail or something? Always a problem here. Hold this in. Get a hold of that sucker. Almost went in on a bit of an angle here. No, it did go pretty straight. There's that. So I got Josh fixing that. We'll put that back on the car. We'll set all the pressures in all the other tires, and then we'll program them so it knows which tires in which spot. Get that situated. At that point, I'll have to call the customer, see if he wants to do the thermostat. I do already have it ordered because I likely have us fix it, and if we do, I'll bring you along through that process. So Josh got our tire fixed. So I got the key on. We're going to go through the menu here. Oh, maybe it's under options. Yep, there we go. So you can see the two rear tires, or what I thought were the rear tires, weren't reading. So we're going to get down. I think we press and hold the set button here. It should put it in relearn mode. And then we'll use our tool to trigger it. I'm pretty sure that's how you do these ones. I could be wrong. Yeah, I think I'm wrong. Maybe that's the issue, because I'm not used to dealing with them with the stick shift. Perhaps the parking brake needs to be on. Let's try that now. Let's try to put it in relearn mode. Hey, look at that. Learned a little something. Perfect. What do you know? You learn something new every day. Hardly ever see these cars with a stick shift. Yeah, millennial anti-theft device is what I call it. And last but not least, there we go. She gave us the double honk. And it says everything is good. I just got to readjust my pressures a little better. And we're golden. So yeah, if you're doing that on a stick shift, make sure it's in neutral and parking brakes on. Napa, now the sponsor, has come through for us. It is now the afternoon. We've got our high-grade stainless steel and copper construction thermostat that meets or exceeds the OEM and is 100% tested and calibrated. So we'll open this bad boy up. And there it is. So there's our heater element. There's our thermostat, the O-ring. That's kind of what that baby looks like. So we can check that real quick. Now Jay is starting to take this thing apart for me. Where'd it go? He's already dropping tools. Oh, man. So to do this thermostat, this air pump diverter valve, can you guys see me? There you are. Sits right down here. It's held on with 3 bolts. So he unhooked the hose from that, the sensor or the connector there, the oxygen sensor connector that runs over here, just kind of get some stuff out of the way. It's moving too quick. You guys see what I'm doing here, right? I played all my cards right. I didn't have to fix the tire or the thermostat. I shouldn't say that out loud. It's my evil plan. We're going to just see what the resistance is, just out of curiosity.
See what the perks of being the boss are.
That's right. Now get to work, boy.
Yeah.
Okay, our leads are good. A known good is 15.7 ohms, or 15.8 ohms, or 16, I guess it's settling around. About 16 ohms, we'll call it, is a known good. So if you're checking yours, just a test light and an ohm meter, and you should be good to go. And we'll go over here, see if he's got a drain bucket under it. And, oh, I put that right in the drawer. So the thermostat housing itself is held on with 4 bolts, and they're inverted Torx. Looks like those little guys right there. So I'll get them out, and then the coolant will drain here momentarily. So have a bucket ready. And if you're lucky, some of it will go into the bucket. Sounds like you're getting most of it down there. As long as you set the bucket by the back tire, you'll catch most of it. You got the secret code to get it unhooked? I didn't look on service data, so I got no idea if there's anything specific. What's the new one look like?
Yeah, sensors in the top.
Yeah.
It's getting caught over on that left-hand side.
Oh, is it?
Something.
Oh, yep, you're right. So it looks like this bracket has to be removed, Jay.
Oh, gotcha. Okay.
Yep.
Is that 10 millimeter?
Oh, probably. So I gotta pull this bracket off. The thermostat housing was hitting, what was it hitting? Just the, where the air pump bolts onto the block right here, the thermostat housing comes out and hits it. I don't know if that's gonna help you or not. You might have, do you have to remove that entire water jacket?
Wouldn't that be a
That's an awesome design.
frosting on the cake, huh?
I'll hold that for you.
I think you're right. You got a whole housing.
Way to go, GM.
Sweet. All because we can't get that off there.
Take something stupid and make it stupider. Awesome. So he's gonna loosen up the water, the whole housing.
Oops.
Okay, see if that'll
Destroy the gasket, huh?
Yeah, hopefully not. Should be an O-ring.
More than 4. There we go.
There she goes. Hey, now just like that, super easy.
Super easy. Alright. Just climb.
I left you some right there. One step ahead of you.
Alright.
Be able to grab that hose and twist the thermostat and get the crack loose or not.
Wishful thinking.
Yeah, sometimes they got a pretty good bond, so he'll get a hose pick, stick a hose pick in the hose here, crack it loose from the housing, and we should be good. And with a little bit of luck, he'll shove it right through his finger.
Or the hose, one of the
No,
other.
don't shove the hose.
You'd rather see the blood than have to buy a hose, right?
Yes. Yeah, your skin will grow back, and that's free.
Yeah.
Just like so.
Alright.
I slip the new thermostat in there, we'll put the bolts in that. If I'd known we had to take this off, I would have gotten a new O-ring for it just to be on the safe side. It is O-ring gasket, so it shouldn't have a problem resealing. Usually good for a couple of tries. Famous last words. So we'll get that torqued on there to factory specs, obviously. Torque the housing back down, kind of get some things put back together here. And the coat should disappear at that point. Yeah, so now he's putting the diverter valve back on. Like I said, it's got, what are there, 3 bolts in that, Jay?
Yep.
Yeah, 3 bolts. Gonna torque them to spec here before we're done, of course, naturally. I unplugged all this for you. That came up and around here. That's for the O2. That's for that.
Out there, right?
Yep, and then you got the air pump connector there.
Oops. Slide back in there.
If you break it, I got it on camera.
Okay, cool. So, man, I have to buy it if I break it?
Of course.
Alright.
There we go. That was like that, and then plug that in. Then I think we're good. Then we'll fill it up with coolant. Now, of course, we've already cleaned up our mess. A little bit of hot water. Just dump it over, let it drain into an approved recycling container, of course. Then just blast it off a blow nozzle, and we'll fill it up with coolant and make sure everything is hunky-dory. So before you start filling up the cooling system, right over there on the passenger side, that little white nut, I guess it would be, it's got the cross in it. That is the bleed screw for the radiator. You have to remove that. That will aid in refilling the cooling system if you're doing what they would consider a static refill, not using like a vacuum fill system. So we're going to elect to do it this way, providing Jason doesn't just snap that right clean off.
Well, if I do, I'll probably drop it on the ground. Don't worry.
It's on camera if you do.
Okay.
You'll be buying this guy a radiator. And I've done radiators in these and they suck.
So we'll be careful now. We're gonna hand you the ratchet if it feels like it's gonna break.
I'll give it to Josh, he's here.
Okay.
Oh, it came right out.
I need something broken?
Yeah.
I'm good at that.
We got 3 of us here. One of us ought to be able to break something, huh?
So he's filling up with Dexacool 50/50 from Napper. Not a sponsor, and as he's filling that, we got to keep an eye on this little guy. Now that's just loose, and that's going to bleed out the air slowly, and that level will go down slowly, and you just kind of keep adding to it until it peters out of here, and then we'll start the car up and top it off, and everybody will be happy. So once it starts petering out of the side of the radiator, tighten that drain, or vent back up rather. We're going to make sure the coolant stays full. We've got the car running, sitting here in an idle. We'll let it warm up. I did not clear the codes out of it. Yes, no, I did clear the code, sorry. So I cleared that code out of it. It has a desired temperature of 221. Right now we're running about 114. All the circuit tests checked out okay on that thermostat heater. It's not commanding it on right now. So we're just gonna watch this warm up, make sure the cooling fans and everything work, make sure everything's happy, obviously make sure the level stays where it should be. And that should be that, folks. Sorry, thermostat just opened. It got up to about 220, I think it was 221, something like that. And then the thermostat just opened. It did draw down a little bit more coolant. Jay's topping that off. Didn't see it command on the heater, so whatever criteria needs to be met hasn't been met yet. Without reading the theory and operation, I don't know exactly when it kicks the heater on itself. That I don't know. I suppose we could take a look and see, but the thermostat does work. Like I said, we could see it open and cycle. The fans never kicked on. I don't know what temperature they come on, maybe 230. Of course, we didn't hit that, so I'm gonna call it a fix, say we're good. Car seems to be happy with it. Our coolant level's full. We've got everything cleaned up down here. I got a mirror and I shined it down under that housing. I don't see any leaks. Everything looks good. In those regards, we should be good. So just doing a little poking here under the theory and operation. It says the thermostat will begin to open electrically at 194 degrees or 90 degrees C and will fully open mechanically at 105 C or 221, which is what I saw when I looked over there. Perhaps I missed it when the heater itself kicked on, or perhaps I didn't. Other than that, it's just your standard wax pellet thermostat. So the computer is satisfied electronically. We know the heater circuit's good. We know the old one's bad, so I'm not going to spend a whole lot of time on it. But I just wanted to look just out of curiosity. It's not a data pit I normally watch while driving down the road to see, you know, hey, is the thermostat heater working? I don't know. So we'll leave it at that, folks, and don't leave me hanging. Not that I said anything about hanging, but don't. Go to the comment section. Questions, comments, concerns, criticisms. You know what to do. While you're down there, subscribe, ring that bell. Find us on our socials, the Facebook, the Insta. And just remember, viewers, if I can do it, you can do it. Thanks for watching.